Hi, I'm going to present nanoscopic resolution within a single frame. Measure is an algorithm that can reduce the effect caused by diffraction in microscopy image at the same time removes the background noise. Common super-resolution microscopy algorithm use a low-resolution sequence to get super-resolution image. This is because the information are stored in along the image sequence by the blinking of emitter. If we have emitter at the limit of resolution, for example, the Rayleigh criterion, this is in the range of 200 to 250 nanometers. We said that we are in the limit of resolution. If emitters are at the greater distance, we can say that they are resolved and we can distinguish these distributions, but we have a lower distance than the limit of resolution. For example, the spatial criterion, we can say that these emitters are unresolved, and we can distinguish with these distributions. So measure is an algorithm of matching super resolution. It has two major stages. Single frame measure that reduce the Fukuyama maximum of emitters is equivalent to reduce the effect of diffractions and perform as a music filter, reducing the background noise. Also can deal with low and high density fluorophore imaging. Temporal measure is processing image stack by application of pixel-wide temporal functions. So how does measure works? First step of measure is the order 0. If we have a Gaussian distribution and apply measure, we get a distribution similar to a invertible Mexican hat. And application of a hybrid transformation, we get measure of order 0. Note that we have maximum of emitter is reduced with the result of measure of order 0. But if we apply measure to Sparrow and Rayleigh limit, we can see that the improve of this distribution. Note that the height at the middle point with both emitter are reduced by application of measure. Measure of higher order is the order step of single frame measure by application of basic operation on images like subtraction and complement. And if we apply this operation in an iterative way, we can see the reduction of the Fukuyama maximum of these emitters. Temporal analysis is the application of measure by single frame image stack, single frame measure stack, and this temporal function could be mean, variance, temporal product mean coefficient of variation, or cumulant of SOPHY. And we get a super resolution image. This temporal function can be applied in several situations. For example, the variance is used when we have a low blinking of a high blinking of emitters, and the mean is applied when we have a low blinking. The other temporal functions are used in an intermediate situation between a high and low blinking. Now I'm going to present measure experimental results. First, we can apply measure to a super resolution image and we get a distribution with better resolutions. You can see here in the inset regions the result comparing the algorithm of Esley, Surf, and Musical, and we get a better performance. Now I'm going to present the raw test of measure under several signal to noise ratio situations. We use PSF check laser lithography The goal is to get a reconstruction similar to a frame. We can see that the application of single frame measure or temporal measure reduce the background noise, and we get the reconstruction similar to a ring. If we compute global index of resolution, we can see a stabilization of these values up to 25 frames, that we can see a confiability of the reconstruction of measure. Here we can see a comparison side by side of measure with several super resolution algorithms like musical, Esley, and surf. Note that surf are affected by the background noise. Esley and musical can remove the background noise, but the reconstruction is not good like the result with measure. And we can see here the result of measure that can achieve resolution at 240 nanometers. In this case, we use nano rulers separated at 40 nanometers. You can see here an example of image sequence and the result of measure. Here you can see selective regions of the result of temporal function of measure. This is using measure, temporal measure of third order, and the result of algorithm of Esley, surf, and musical. Note that this algorithm couldn't resolve the emitters. And we have implementation of measure in MATLAB, R, Python, and Fiji. This is the link to the plugin for Fiji, and here we can see a picture of the plugin of measure for Fiji. Note that measure can use GPUs for accelerating computing. And we have preprint of this algorithm of bioarchive and research squares, and is current in revision for National Communication Journal. Thank you for your attention.